Hello and welcome back to another VHDL tutorial. In this video, we are going to study how to design or write code for the encoder. We are going to write uh, 4x2 encoder in this video, and we will be discussing 8x3 encoder in a separate video. This is how an 4x2 encoder looks like. An encoder has 2 raised power n inputs and n outputs. It converts a sort of this kind of inputs into a short outputs. Here the 4 cross n encoder looks like this. This is the truth table of a simple encoder in which this is the most significant bit and this is the least significant bit. These are two outputs, y0 and y1. Based on the bit that is high, we get the output. For example, if the least significant bit is high, we get the output of 0, 0. If second bit is high, we get 0, 1. If most significant bit is high, we get output of 1, 1. This output is determined by which of the bits is high, is active high. For example, if the D2 is high, we will get the corresponding output with respect to this, that is 1, 0, which correspond to 0, 1, 2. 0 1 2, and for most significant bit in this 4 cross 2 encoder, the output will be 3. But we are not going to write VHDL code for this encoder. We are going to write the for priority encoder. If we look at this encoder where we have some hard coded inputs, like we have this sequence of 001, then we will be having output of 00. If we have 0010, then we'll be having output of 01. But in case here, instead of 0, if we have another one, then it will get a problem. That if we have to choose the output based on this bit or this bit, as I have previously said that the bit that goes active high will determine the output in this encoder. So in priority encoder, what we do that we keep all the terms to the right of the bit as don't care. Like we have mentioned here, these crosses represent don't care terms. The, as this is the most significant bit, this is the least significant bit, we set a priority of the bits that if this bit is high, show the output based on this bit irrespective of the other bits to the right of this bit. For example, if this bit is high, if the most significant bit is high, show the output 1 1, whatever are these two three bits. These may be 1 1 1, 0 0 0, or 0 1 1. We don't care about them. So what this priority encoder is, we set some priority of the bits. Like here, if we have this sequence of 0 0 1, then we will show the output of 0 1. We don't care what is here or at the this bit number 0. If it is 1, still it will show the output of 0 1. If it is 0 or 1, it won't affect the output. So now we will be coding VHDL code for this type of encoder, that is 4 cross 2 priority encoder. Let us start with create a new project. Next, this all exists. Create a file. Next, next, select any device here. Now we have to configure our ports. As here we will be having four input bits like as bit number 1, 0, 2, and 3. In previous videos we have taken the bits as separate, but here we will be using another type, that is a vector, which will be having four bits. Like if we write here input as in, and we'll be check marking this bus, which will be having, which will be a bus of bits from 0 to 3, that will be having 4 bits. Likewise we will be having encode, we'll name it encode, and it will be out, and it will be a bus of 2 bits, 0 and 1, bit number 0 and bit number 1, that is here. Okay, it will create the file under simulation sources sim1 encoded encoder. So we'll maximize it. If we look here, if we have to find the boolean function for y1, we can get it easily here. And if we want to get boolean function for this o0 and o1, we can get it easily. But if we have encoder that for example, if we have 8 cross 3 encoder, uh, it would be very difficult for us to get the boolean expressions for functions for these outputs. Instead, what we will do, we will be using case, that case we will be writing, if we encounter this type of sequence, we will be showing the output of don't cares. If we encounter this type of sequence 001, we will be showing 00 as output. If we encounter this type of input, like if we encounter 001 and don't care, we'll be showing 01 as output. If we encounter 01 and don't care terms, if we encounter then after this, if we encounter 0111 or 0101, we will be showing same output for all these cases, that is 10. For that case, we will be using case statement, and the syntax for that is, we'll have to write process, and we have to give the input here, we have to begin the process and then end the process, and we have to initialize case like this, and we have to end the case also this. And now we have to write different cases here. When we say when, if we encounter, this type of sequence 000, we will be showing our encode as don't cares. These dashes represent don't cares. Now I'll copy this. If we encounter this type of sequence 0001, we will be showing output of 00. If we have this type of sequence like 001 and don't care, 001 and don't care, will show output of 01. If we have a sequence like this 01 and don't cares, will show the output of 10. If we have an uh, input bus of 4 bits like this, 1 and 3 other bits, we don't care what are those, those may be 111 or 000 or whatever, we'll be showing the output of 111. After all these cases, we have to mention one case, that is when others, and this is very important, we have to write this. Then we will be showing encode as don't care. It means that if the input does not match any of these, then we will be showing this type of output, that is these don't cares. Here we have the input type of std logic vector, which has 4 bits, is a bus of 4 bits. Encode output is the bus of 2 bits. Okay, save this, run synthesis. It's running here. I hope this code is clear to you. This is like switch statement in other programming languages, like in which in C we have switch uh, statement. This is same as that. Here we are using when instead of case, and case we are using there we use switch instead of case. Okay, since this is complete, now if we minimize it, we go to the simulation sources sim1 encoder sim1. We create another file of add simulation sources. We create a new file. We name it encode tb. We'll be writing test bench file, then finish. Okay, till then we will copy these ports from here. After that, the file is here in the simulation source folder. We'll click on it, maximize it. After this architecture, we write component encoder, name of the component in the design for and component. After that, we will initialize the test bench signals and write. We'll copy their type. Input is a bus of 3 bits, 4 bits, and output is a bus of 2 bits. Okay. After that, after begin, we will write dut code. Dut represents this component here. Encode will map the ports to TV. Encode TV. Okay. Now we will write the some test cases. Encode encoder. What we have here? Encoder. We have encoder. Okay. After this, we will write process begin. We will end the process. After that, we will write some inputs like if we have input, we write first case here. If our input is 0 0, we'll check what will be its output. Then we will wait for 100 nanoseconds. Then we will test a case for this last one, this one. We will write the don't care terms. We will put their values and we'll check what will be output for them. Like we will write, we'll copy this and paste it here. Like if we have 100, what will be output for this? If we write 1111, we write 1010, and if we write 1001, the output for all these should be same as we have written code for the priority encoder, which means that if the most significant bit or higher bit is active high, the output will be corresponding to that. In all these cases, the most significant bit is high and output should be corresponding to that. So let's test this. Run synthesis, behavioral simulations. So let's maximize it. Um, Here, for the first case 000, we have written that for 000, we have written the output should be don't care. Here we have don't care. For 1000, here we have most significant bit is high, so output should be corresponding to that. For most significant bit to be high, the output should be 1 1, that is 3. These are the hexadecimal representations of these bits. The output is 3. For all ones, output is 3. For 1010, output is 3. For 100, output is 3. So let us change them out in a. If we write 0 here, if we write 0 here, let us test this one. Yes. Okay. For the first case, it is same. For second case, the most significant bit is 1. The output should be 3. For the second bit is high. The second most the bit after most significant bit is high. That the output should be 2. If we have encountered 0 1 sequence, if we encounter 0 1 sequence, the output should be 1 0. The output should be 1 0 here. Here, there our second bit is high. 0 1, output should be 1. Output is 1. For 100, the most significant bit is high. The output should be 3. So our truth table is verified and our code is correct. You can add more cases here by your own and test them. In next video, we'll be discussing 8 cross 3 priority encoder. Till then, goodbye. Thank you.